Hello viewers, you're welcome back to my channel. So this video we'll be looking at 9.1, which is about vectors in two dimensions. So we'll start by the first video. Will be discussing the description of vectors. Now, how do we describe a vector? So we have a short note here. It says a vector is a directed line segment, and the length of the line segment is called the magnitude of the vector, and the direction is given by an angle, which we will discuss later. So if you look at this is a directed line segment. You can see it has a head which goes to the terminal point, and here is called the initial point. So one thing that is important is the magnitude, which is simply the length of the vector. And we say that we can denote a vector by using a bold V, or you have this V hat, right? And we can denote the magnitude of the vector using this absolute value, or you use the double bar. So all of this means the same thing. It means the magnitude. And here we have a brief description about what are equivalent vectors. So we say two vectors are equivalent if they have the same magnitude and direction. So for example, if you look at these two vectors, if you look at these vectors now, this is u, and this is 2u. So you can see the longer the magnitude, if you multiply this by 2, this vector is longer. And you can see if you look at vector 2u and minus 2u, they're almost the same length, so they have the same magnitude, but they have opposite direction. So that is why one is going up and the other one is facing downward. So if you multiply a vector by a positive number other than 1, it changes the magnitude, right? So for example, here you have u, and this is 2u because you multiply by a positive, so it becomes longer. But if you multiply by minus u, it doesn't change the magnitude, but it reverses the direction of the vector. Okay. And one thing here is talking about resultant vector. So when we talk about resultant vector, we are simply talking about the sum of the two vectors, A and B. So for example, if you have the sum of vector V and its opposites minus V, is going to have a magnitude of what? Of 0. And that is what we call the zero vector. So if you look at this diagram now, this is just talking about how to find resultant. So if you have two vectors, for example, this is a vector, something that is important is what we call the head-to-tail arrangement. So we call it head-to-tail arrangement. So now what will be the resultant? So A and B, there is a tail-to-head arrangement. So the resultant will start from the tail of A and to the end of B and to the head of B. So this AB is the resultant vector. So it's like the sum of the vector. Now, if you take vector B, if you look at vector B and vector A, right? Now, if you look at A and B, what happened? You have tail-to-tail arrangement. So it means that you need to do some rearrangement here. So this vector B here is the same thing as this. So this is also vector B, right? So now you can see there is a There is a head-to-tail arrangement here, because here you have the head of A meeting with the tail of B. So this is B. B will also have this direction as this one here. So here you can see now you have head-tail, right? Now, since you have head-tail, it means the resultant, just as we discussed, is going to start from where? The tail of A, and it's going to stop at the head of B. So this is the resultant vector. So this AB is the resultant. Okay. All right. Now we look at this one, this vector here. Now this one, what we can do is what? We can say this is vector A. So if you look at vector A, look at vector A and B, you can see between A and B, what we have is what? Is tail to tail. So which is not good. Then we have to rearrange it. This we can reverse the direction. So this becomes minus B, right? So if you have this as minus B, but this vector A, you can write this also, you can move it here. So this is also vector what? Vector A. They'll have the same magnitude and the same direction. So you see now here we can see that there is a what? There is a head tail or head tail head. You can call it head tail, right? Now, since there's a tail here, it means that this can be a resultant, which is going to be A plus what? Minus B, because this is now minus B. So this is just how to find resultant vectors. Now let's just answer one question here. If you look at this question, you are given three vectors or four vectors. V, I think is U, this will be U, V, P, and Q. And you want to find vector P. So we're just going to use the ideas of resultant. Now, when I say resultant, the first thing you should be looking out for, first of all, you need to have head-tail arrangement. And you see this vector Q, for example, if you look at this, this is U. This also can be seen as U, right? Which will have the same direction. So it means that there is a head-to-tail arrangement between U and what? And V, right? This point. So this is head-tail. So what does that mean? It simply means that what? The Q is going to be the resultant, right? This Q is going to be the resultant. So it means that Q is going to be the same as what? As U plus what? Plus V. Why? Because there is a head-to-tail arrangement here. So the resultant is going to be from where? From the tail of V to the head of what? U. And then here we already know what is Q. So Q is giving us 7, 9 from here. It's equals to, we know U is minus 1, 7, then plus V, which is the vector we don't know. So we can find V. V will just be by subtraction. You move this to the other side. So we have 7, 9 minus what? Minus 1, 7 as well. This is equals to V. But what is this one? This one is simply subtracting two vectors. We do it component-wise. We'll discuss about this later. So this is going to be 7 minus minus. So this is plus 1, comma, 9 minus 7. And this will give us our vector V. So this is just going to be 8, comma what? Comma 2. So this is our vector V. But what are we interested in? Are we interested in V? The question wants us to find the vector. Is it P? Yes, vector P. Now, we can also see something here, right? We can also see that there is a what? There is a tail to head arrangement between what? Here, actually, there are two tail to head arrangement. There's also a tail arrangement between V and what? And P. Because this is the head of V, and this is the tail of what? P. This is the head of V. So this is the head of V, and this is the tail of the green one, which is what? Which is P. So it means that the resultant is going to start from where? The tail of P, no, the tail of V to the head of what? To the head of P. So this vector here is the resultant. So it's the resultant of what? Of U and P. No, sorry, of V and P, vector P. So it means that U is nothing but what? But P plus V. And remember, we want to find P, so we can just make P, solve for P, which is just going to be U minus what? Minus V. But what is U? We already know U is given as minus 1, 7, minus V, which is just 8 and what? 2. So this is going to be minus 1 minus 8, comma, 7 minus 2, right? And this is going to be minus 9 and what? I think minus 9 and 5. So this is vector P. All right. All right, so let's talk about vectors in a coordinate plane. So we said if you have a vector, if a vector is placed in a coordinate plane, it can be described by its what? By its components. And how do you describe a vector by its components? So for example, if you have a vector P, this is a vector P, and its initial point is given by x1, y1. So this is the initial point, x1, y1. And the terminal point is what is given by the q, which is x2, y2. So this is q, x2, y2. So this is the vector v, right? So vector v or u, I think this we can write it as v. It's okay. So what can we do here? So our vector v, how to write it as a component, is simply be what? It simply be x2 minus x1, comma, y2 minus y1. So this is what we call the difference between this is simply what we call the vertical component, which is this. So this is your vertical component of the vector. This is the vertical component of the vector. And this will give us the what? The horizontal component, which is simply x2 minus x1, right? Okay. So let's see, we have this example 2 here. What is this saying? It's just asking us to find the components of a vector AB. So a vector AB whose tail is what? Is minus 2 and 5. So its tail is going to be somewhere here, maybe. Minus 2 and 5. This is the tail. And whose head? The head is where? 3 and 7. So it's going to be in the first quadrant. So you just have something like this. Say this is 3 and 7. So this is a vector we're talking about. And just like we did, if you want to describe this vector in terms of components, you just need to do this, right? Yes, so it means the vector AB as a vector is going to be what? Use the formula, which is x2 minus x1, comma, y2 minus y1. And that means that what? You will have x2 is going to be 3, so minus 2, comma, and y2 is going to be, so this is 7 here. So this is going to be 7 minus 5. And the vector is simply going to be 5 and what? 5 and 2, right? Is it 5 and 2? Yep. All right, so we will stop here now. In the next video, we'll look at how to find the magnitude and the direction of vectors. The magnitude and direction of vectors.